Greetings! Welcome to the first edition of Science by Mr. Healy. In this episode we'll be looking at mass, volume, and density as well as their interactions, and a bit of algebra. Okay, we know that matter has mass. Mass is the total weight of all particles in an object, i.e. atoms. Weight is dependent on location, for instance, Earth versus another celestial body. We'll talk about how location can affect weight later on in another episode. Since mass is a quantitative measure, it uses instruments instead of observation to collect data, a unit is assigned to it. An example of a unit for mass is grams. What else? Space. Space?
Space, the final frontier. These are the voyages of the starship Enterprise. Its 5-year mission, to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
Well, more precisely, space that an object occupies. And the term used to describe this space is volume. So now, what's the connection between mass and volume? Well, let's look at another item, density/concentration. According to Wikipedia, the density of a material is defined as its mass per unit volume. Well, what that means is if a substance A is dissolved in another substance B, the density or concentration of this mixture is a numerical value that informs you of the amount of A dissolved in B. For instance, take 2% milk. 2% means 2 grams of fat dissolved in 100 ml of milk. If you have 2 liters of milk, or 2,000 mLs, then the total amount of fat is 40 grams. Let's look at that. Math time. But before we do so, let's look at some algebra. Now don't let algebra bring you down. It's really simple. Things you know before we get started. Algebra involves the use of variables such as x or y or z or any other letter that can designate any number. Imagine that algebraic equations are scales. A scale can be tilted if you add, subtract, multiply, or divide either side. So what you do on one side of the equation must be done on the other. Let's take a look at the following example. 2x plus 2 is equal to 8. What is the value of x? Well, my objective is to solve for x. To do so, I have to isolate the x, which means have the x by itself on one side of the equality. Well, we'll start by subtracting the 2 being added because that will eliminate that 2. But remember again, what you do on one side, you must do on the other. So 2x plus 2 minus 2 on one side is equal to 8 minus 2 on the other. This leaves us with 0 on one side and 6 on the other. So 2x is equal to 6. Now I have to eliminate the other 2 that is multiplying the x, which is called a coefficient. To do so, since it's multiplying the x, I will divide it by 2 because the opposite of multiplication is division. Again, what you do on one side, you must do on the other. 2x over 2 is equal to 6 over 2. The 2's cancel each other out, and the 6 divided by 2 gives us a 3. Now try solving the following equation by yourself. If if you solved correctly, you would know that the x is equal to 3, again in this case. So now let's go back to mass, volume, and density. Let's look back at the 2% milk. 2 grams of fat corresponds to 100 mLs of milk. But what about 2,000 mLs? As you can see, I designated an x. In step 2, I will cross multiply. So 2 grams of fat goes to 2,000 mLs, and the x goes to the 100 mLs. As you can see in step 3, we have one line now where x times 100 ml is equal to 2 grams times 2,000 ml. Again, I can do some algebra now and isolate the x. So I divided the 100 ml on one side and I'm dividing on the other. As you can see in step 4, x is equal to 2 grams times 2,000 mLs over 100 mLs. You see there are slashes over the mLs. Well, the mLs cancel each other out. In step 5, after reducing, I'm left with 40 grams, which is dissolved in 2 liters of milk. Let's look at the 2% concentration again. So 2 grams correspond to 100 ml. That 2 gram represents mass, and that 100 ml represents volume. So we get the following formula for density and concentration. D is equal to m over v, C is equal to m over v, where D stands for density, m is mass, C is concentration, and v is volume. We can play with this formula to find mass or volume separately. But before we start, let's imagine there's a 1 under the D. So D over 1 is equal to m over v. Again, we'll cross multiply. D goes to the v, 1 goes to the m. And in step 4, we get that one line. D times v is equal to 1 over m. In this case, I want to isolate the m. So to do so, I have m is equal to d times v over 1. So m is equal to d times v. Let's try the same steps, but this time with volume. Again, before we start, let's imagine there's a 1 under the d. So d over 1 is equal to m over v. Again, we cross multiply to isolate the v. D goes to the v, 1 goes to the m. In step 3, we get that one line, d times v is equal to 1 over m. In this case, I want to isolate the v. So what I'm left with is v equals to 1 times m over d, or v is equal to m over d. Let's take a break. Okay, enough of that. Another way of playing with the density formula is by using the triangle method, which is a shortcut, a good one. Now imagine that there is a triangle. When you wish to place the formula in your triangle, you would do as follows. The m goes on top, the d times v goes under. And you'll follow this kind of triangle all the time when it comes to this formula. Later on, we'll see how you can create these triangle formulas. So let's see how this triangle works. Let's say you're looking to find the formula for density. I know you already know that it's m over v, but let's try. Well, here's what you do. First, place your hand on the letter D. As you can see, the D is now hidden. What you're left with is m over v. So the formula for D is equal to m over v. Let's do the same with m and v. Again, we'll hide both letters at the same time. What you're left with, on one side, v is equal to m over d, and on the other, m is equal to d times v. And that's it for this triangle formula. That's it for today's lesson.